Today on Zero Fuel Required, we've been invited to review a product. We invite you to review a product. So this company kit called, I hope I don't butcher the name, Xingou. They invited us to review their kit that is a physics-based electromagnetic experiments with the experimental manual itself included. So we received it today in the mail. You purchased it through Amazon. That's where it came from, Amazon. Help. Today I have my helper.
It smells like stuff.
Okay, this is Nicholas, my son, who's helping today on this project we're doing here. You're gonna pull it out, lift it out, and I'll move the box.
Oh, I thought it was in a bag. It's like
It is in a bag.
not this kind of bag. Like a zipper bag.
Okay. So this is how they packed it from Amazon. Alright. So, okay, this is right out of the package.
Okay, put it down, please.
It's a zipper case.
Are they balls?
Open it. Alright.
Is that a beard? Is that Santa's beard?
Kind of looks like a beard, doesn't it?
Yeah.
Alright, so, there's a lot to this kit. Okay. So we'll start first with the experiment manual. This is experiment manual, electricity and magnetism kit. Thinking, observing, questioning, and experimenting. So this kit, I think what it says online is that it's for like 8 to 12 years old and up. I'm sure it's for an adult like me too, because you know it's neat. But I don't know if it's a kit that you would just say here and hand it to your kids and say go play, unless they had a run through under understanding the whole kit to begin with on how to operate it. So I would think that as a parent you should run through it with your child first in the experiments, and then they could probably go off on their own and experiment. Obviously, the younger they are, the more likely they'll need some guidance. So, in the kit, I'll just show you real quick. A cloth, a fuzzy yellow
Beard.
Santa Claus beard.
Should I put this on my chin?
You want to put it on your chin?
Ho, ho, ho.
Okay. This is a potentmeter. Potentmeter. Let's see. Yes. Like I said, voltmeter. Voltmeter. Amp-meter. This is a battery case. Then you have here. I'll fold it before. I'm trying to figure out what everything is in here. Okay. Slow down here for a second to figure out what we have. Voltmeter. Multifunction car. That's the car body to a car. So we have U-type magnet. This is a I'm gonna say it's a round magnet. Ring magnet. There. A bar magnet. And so, this parts bag. Let's see. Oh, okay. This parts bag has other small parts, it's called, but it looks like it's got a propeller in there and maybe a like an actual windmill propeller or boat propeller and wire and light bulbs and alligator clips and all kinds of goodies in it. Alright. We have a small bell. Bell. Another magnet with wheels. The magnet with wheels. Magnetic car, it's called. Magnet wheels. And you got a compass. Here we got to show the camera. Compass. And let's see here. So we got the battery. This is a solar panel. This is a buzzer, like I said. That's the beeping or buzzer. Some LED lights. And this is a electric motor here, small motor. Trying to figure out what this is. Oh, this is a copper guide. A copper guide. In the picture is shown like this. Like that in the picture. So a copper guide. And that's pretty big. Place there.
Did you get this?
This is a hand crank motor.
Did you get this?
No. That is a electromagnet. That's pretty cool. And we have here the fixed resistance, and here
Pointy.
small lamp holders. So you have 1, 2, 3. They're lamp holders. You put little light bulbs in, so that way you can have things light up as you're doing experiments. And then you can see here we have 1, 2, 3. They're on off switch.
Is this supposed to have a spike in it? The other ones don't.
We haven't gotten that far yet. So we have 3 switches. What is this? It's pretty pointy. It's like a thumbtack almost.
Yeah, and then there's these, which can go like this. Almost like Legos.
Yeah, I see they stick together. And this last one here, we have some other little electric motor. It's a very, comes with a little screwdriver inside. And ooh. This is looks like iron. Can you see that on there or not?
Mm-hmm.
It's the iron sand. So that's in there too. And let's see, what is, yeah, that one's called iron powder. So that's it. The box is empty. It's a very interesting, very thorough, neat case to carry your whole experiment kit, magnetic experiment kit. We identified everything that's here. There's everything but these. Gotta go in there. Yes. Right.
But why is the top one spiky?
Right. So, well, this is probably has to go with you having experiments. You can put different height.
Can they go here?
No, that's a buzzer.
Oh.
Different experiments we can do with this kit. Okay, in the book, we're looking at the experiment manual. Just do a real quick table of contents for there's 2 main chapters in the book: electricity and magnetism. Create a simple circuit, series of circuits, and parallel circuits. How to use an amp meter. What is a light emitting diode or an LED? The current in a circuit, resistance, potentmeter, how to use a voltmeter, basic rules in series circuits and parallel circuits, relationship between voltage, current, and resistance, measurement of unknown resistance by current voltage method. And then there's the chapter, a whole section on magnetism. What is a magnetic field? Magnetic effects of electric current. What is electromagnet? Forces on currents in magnetic fields. To know the electric motors, electric generators, a fruit battery, you can do a fruit battery, building an electric bell, and other experiments. This learning kit, here is perfect for anybody. And it's very complete, very thorough. It appears like everything's here to do any kind of experiment related to electricity and magnetism. You know, the basics to get learning, get curious minds working and learning how this stuff actually functions. It's great for just about anybody, and it's also great for homeschool, which our family, our children are homeschooled. In this book here, the book is full color, 42-page full color experiment book. And we're going to go through some of the experiments inside of the book here. Sure, the pictures are all in full color. As I flip through the book, gives you all the information about, to learn about electric and magnetism. Describe conditions that create current in an electric circuit. The precautions are the wire and light bulbs may be hot if connected across the battery for a long period of time. Do not connect the wire directly across the battery without any appliance. This will possibly destroy the battery.
Does it mean explode?
Yeah. Well, I don't know about this. It's explode.
Like
so what materials do we need? 1.5.
1.5 minus V battery, AA battery.
V is in volt. AA battery.
1 light bulb, 1 lighter, and wire.
1 light bulb.
If there's none there, I could possibly get 1.
No, there's 3 light bulbs in this kit. So,
I know I small light bulbs, but not this small. What's this stuff on the side?
Glue.
Oh.
Okay. 1 light bulb.
Red one, right?
You have 2 connections to make. The side is one, and the bottom is the other. Now, you have to power the light bulb from the battery. How are you going to connect?
Like that. I did it. It's kind of labeled, but you can barely see it. Can you help? Can you put that wire on the side, please?
Yay! So what did you do? What did you do to the light bulb?
Powered it.
Okay, but how though? I mean, if you powered the light bulb,
I connected it
you connected it how though?
by putting it on one side with the wire.
On the negative side to the
Yeah.
positive. You touched it on the top. Yeah. Did you learn anything?
Kind of. I learned that now if we have a power out, we can just do that.
Yeah, you could sit there and hold it all night long in a power outage. Okay. So you wired a light circuit up here, right? You got. So how does the current go through your light circuit? So
Red wire, black, red wire, red. Wait.
yeah, no. So
It goes like.
so yeah,
this?
your circuit goes. Your positive is going to here, and your negative is going to the opposite side of the light, and then you've connected between, and you put a switch to make a connection, like an on-off switch. So what's it do when you? Does it work?
Yay! And it's.
So now Nicholas is wired in a parallel circuit, the third parallel circuit, and we're going to see what happens.
Cow.
Oh, the amp meter doesn't go as high, but look
Oh, it's at 2.
look at how you can barely see that bulb and that bulb.
It looks like there's a tiny little sun in it. That's probably how bright a tiny little sun
Okay,
would
so
be.
we're pulling 0.4 amps. So here it's a perfect example of this bulb used 0.16. This bulb, the LED being on all the time, used 0.4, and this here is pretty much under 0.1 of an amp because it's flashing all the time. It's not on all the time, consuming electricity. So it's a perfect little experiment to show you energy consumption using the amp meter and the light emitting diode. So we've gone through a couple experiments in the book, and it's very educational for the children, and the books are very clear in the instructions. There might be a few misspelled words here or there, but all in all, I'm happy with it so far, and we've literally got a few hours into the experiments here. There's 21 experiments, 42 pages, 21 experiments. So, and each experiment, they ask you, what, go ahead.
This blinks lights like a Ferris wheel at night.
Yeah, everyone has an objective, precautions, materials that you need to build the project, procedures, what you do, like I want to assemble this to this to this. They'll tell you in a procedure on how to assemble it, and then you analyze what you've done to build your project. You analyze it, and then once you're done analyzing it, you can write down your results and move on to the questions in what it analyzes, and then basically you summarize your experiment, you know, and you actually learn something. Okay, now throw your power on.
Yay.
Okay.
And is 0.2.
Let's see how the needle's moving.
Oh.
It's not a steady 0.2 or 0.02. 0.2. It's just the needle's at 0.2,
like,
but it's jumping like this because of the flashing light. So it's not a steady 0.2. It's moving, but this is using almost 0.2 of electricity, and this is using less than 1. So the needle's moving. So what I was saying is that you want to make sure your wiring is correct before you hook everything up, because you don't want to short something out because it's wired incorrectly. Just like anything, if you wire a house or wire a car, you hook the wire up incorrectly, you're going to burn something out. So these are sensitive little electronics. Even though they're a home set for learning, you still can burn something out if you hook it up incorrectly. So just be careful, be wise of what you hook to. That's why I said, you know, keep an eye on what your kids do, because they could hook something up improperly and burn it out. Precaution. Wire and light bulbs can be hot if connected across the battery for a long time. So it's written in the books in warnings. So that's why it's to keep, you know, to watch what your kids are doing, keep an eye on what they're doing. But every page for like the experiment we're currently doing, even though I have both sets, both LEDs hooked up, they have a full color image of what's going on. They have schematics. They have schematics on the pages, so you can correctly wire things. And there's images, literally full color images on every page. They're nice glossy pages, and you can identify easily what these items are when you have them wired up. Okay, this isn't even one of the experiments in the book. There's probably way more things you can do with this kit than this book even covers. But what I'm showing here is, so there's two LEDs on here, and here's a multi-switch. So you can go from one side to the other. But the whole reason I did this is, instead of having to switch from one to the other to measure the voltage or the amperage running through it, you can throw it one way, and it measures the amperage, and then you can go the other way and you can measure the amperage for the other bulb, and so you're lighting multiple bulbs with just being creative in your wiring and understanding the circuitry on you actually being able to measure the amperage both ways. You just play with it, and you know, as you go along and learn each chapter, as you go along and learn, and probably by the time you get done this book, your kids will be able to go and play and do more projects than what this book actually shows.
Yeah.
Okay, so we went through the first couple chapters in the beginning of the electric part. Now we're just doing the magnetism part, and we're doing just a couple of things on the magnetism. The first thing we're doing is we're taking and placing the objects, the bar magnet, the U magnet, and the compass, and the iron pack. So we have the bar magnet, the compass, and iron, and he's got the U magnet. Does it do anything to the compass?
Barely.
Hold on, let's move these out of the way. Don't, no, not so close. Move away from the compass. Does it move the compass?
Yes.
So it shows it's magnetized. So this is like the first thing they show you in the first chapter of magnetism, and then it goes into, you know, the magnetic fields and doing different things with the magnets. All right, so we've done just a handful of little projects in this kit, and the last one we're going to do for the video is the wind-powered car, which is shown on the back page here. I should put wires in the less. Oh, just put wires on. See this here. Switch is just kind of over here, I guess. All right.
How does it feel on the picture?
It's just sitting in there. Just sitting there. Now what you can do, is put your wires down, catch everything. Just color them.
These are pretty good on its own.
Alright. So we switch the polarity on the
Oh,
battery.
it's actually going without doing anything.
So if it's a hot day, you just want to cool yourself. Use your car.
Watch it drift.
What have you learned today? A lot? Yeah? And you want to play with this more? Do more experiments? Yeah? Definitely. Yeah, it seems like a fun kit, and we've been here for like almost 2 hours, and we've only done a handful of experiments, and definitely learned stuff, right?
Mm-hmm.
Yeah. So, do you like the kit?
Yep.
Are you ready to do more?
Yeah.
You ready to learn more?
Yep.
Yeah. There's definitely a lot to this kit. I think there's so much to learn, and it's such a well put together kit. You know, the instructions are pretty clear on everything, and I love how they're, you know, full color pages, so it's very easy to read and understand. So there's so much to this kit, and we haven't even scratched the surface on what there is to learn in this kit and these books, and all the playing around that the kids can do with this, even on their own time. Once they understand the electrical circuitry, they're not going to fry anything. You know, you don't want to damage what you have. But there's a lot to it, you know, between learning the diodes. You know, there's a lot of stuff to this kit, and there's going to be many hours of fun and learning with this kit because it's very well put together. It's nicely packaged in the box. You know, there's a space for everything to go back into it neatly, to put it out and be used over and over again. So if you're interested in purchasing this kit, we'll have a link down below. Okay, so I hope this helps you in your decision to buy or not to buy the Xingou Electronic Science Kit. I guess that's it for now.
Like, share, and subscribe because you never know what we're going to do next.